All right, Chapter 6, final segment. This segment is all practice problems. So again, if you have been getting the gist of this chapter as it's been going, then you may or may not want to hang around for the 15 minutes that it's probably going to take to go through these 9 slides. Um, Again, I do recommend that you just, at the very minimum, fast forward so you can see the style of problems that we'll have, and then we'll go through them. So, calculate delta H reaction using the delta H formation for the reaction. So we have 4 ammonia plus 7 O2 going to 4 NO2 plus 6 water. So we'll go look up each one of these values. And so for ammonia, we get 34, whoops, I fib. For the NO2, we get 34 kilojoules. For the water, we get negative 285. And then for the ammonia, we actually get negative 46. And then for the oxygen, of course, elemental would be 0. We sum these up, moles will all cancel out, so we get 136 minus the 1715 plus 184, and that gives us negative 1395. Now we can actually check this using Hess's law. So 4 times the ammonia minus, 4 times the ammonia going to half of N2 plus 3 halves of hydrogen. We 4 times the delta H, 7 times the water, 7 times the oxygen will be 7 times the delta H for the oxygen. 4 times the O2 plus the half N2 going to NO2 would be 4 times the formation of H. Oh my gosh, will be 4 times the delta H sub F for the NO2. And then 6 times the H2 plus half O2 going to water gives us the formation of water as a liquid. Right? When we sum those up, we get same as before. Okay, so whether we do it one way or the other, it's not going to matter. All right, you don't always want to know delta H reaction, so you can use Hess's law and delta H reaction to calculate the formation for a compound when it's not known. So in other words, if you have a compound that is not tabulated, then you can actually use Hess's law to figure that out. So given the following data, what is the value of delta H of formation for C2H3O2 minus, right, for the acetate ion? So we have sodium plus the acetate plus 3 waters gives sodium acetate and 3 waters. We have a value for that that's negative 19.7 kilojoules. So sodium plus the delta H of formation is going to be minus 239.7. The sodium acetate with the waters as a solid is 710.4 kilojoules per mole, and water is 285.9 kilojoules per mole. So the delta H for the reaction then, for the delta H of formation of the sodium acetate with water minus the delta H of formation of the sodium aqueous, delta H of formation of the acetate aqueous minus 3 times the delta H of the water. So we can rearrange this so that we get the acetate ion would be equal to the formation of the sodium acetate with the water minus the delta H of the sodium minus the delta H of reaction minus the 3 times the delta H of the water. So again, we can start plugging values in here. So we have 710.4 kilojoules per mole minus a negative 239 minus a negative 19.7 minus 3 times negative 285.9. That means it would be positive 406.7 kilojoules per mole. So again, if we know the reaction and we know the majority of the components, we can just rearrange to solve for the component we're after. All right, calculate the delta H for this reaction using delta HF data. So we have 2 iron plus 6 water going to 2 iron 3 hydroxides plus 3 hydrogen gas. Delta H of formation, 0 for the iron, 0 for the hydrogen gas, they're elemental, negative 285.8 for the water, and negative 696.5 for the iron 3 hydroxide. Delta H of reaction then would be 2 times the formation of the iron hydroxide plus 3 times the formation of the H2 gas minus the reactants, which would be 2 times the formation of the iron minus 6 times the formation of the water. And then plug those values in, so we get 2 moles times the negative 696, plus 3 times 0, minus 2 times 0, they were both elemental, minus 6 times the 285.8. We get negative 1393 plus 1714 gives us a final value of positive 321.8 kilojoules. Right? All right. So pause here and give this one a try on your own, and then I'll go through it. So we've given you the delta H formation of each piece, and it wants to know what is the delta H of the reaction. All right. So hopefully you took your products, O2 and methane, and then you're going to subtract your reactants, the CO2 and the H2O. We have 2 times 0 because oxygen is elemental, plus 1 times negative 74.8 for the methane, minus 1 times negative 393.5, that's going to be for the CO2, minus 2 times negative 285, that's for the water. Moles all cancel out. You end up with negative 74.8 plus 393.5 plus 571 gives us 890.3 kilojoules as a final answer. So hopefully you're knocking this out. All right. Calculate delta H of F for FeO solid, so for iron 2 oxide, using the information below. Delta H F values are shown below each substance. So again, here we're going to do a little rearranging. They gave us delta H for the reaction. They gave us the formation for the Fe3O4. They gave us the delta H formation for the CO. They gave us the delta H formation for CO2. And they're asking us, what is the delta H formation for iron 2 oxide? There are our options. So you might want to pause here, work your way through it. Hopefully you came out with negative 272.0. If you didn't, here's what you should have done. So we know the delta H of reaction will equal the sum of the products minus the sum of the reactants. Delta H of reaction then will be 3 times the FeO that we're looking for, plus delta H of formation of O2, which we know is 0, minus delta H of formation of the Fe3O4, plus the delta H of formation for the CO. All right. It's important that we don't forget that 3 is there. Back here, where'd that 3 come from? There it is, right there. We're going to make 3 of them. Can't forget that guy. All right, so we get 21.9 kilojoules is equal to 3 times HF of the FeO plus the negative 393.5 minus the negative 1120.9 plus the negative 110.5. All right. And of course, the oxygen is gone here, right? So the negative 393, just double check that. 393 is for the CO2. Getting a little confuddled right in here. So this is O2 gas, but there is no O2. So that's the typo that's kind of messing with me. I hope it's not messing with you. This should be CO2. Right in there. It's like O2, we didn't have any elementals. All right, so negative 393.5. Now, we're going to subtract the 1120.9 from the Fe3O4, and then we're going to add the negative 110 from the CO. That means we get plus 21.9 for the reaction is going to be equal to 3 times the delta H of F for the FeO plus 837.9. Of course, subtract 837.9, that gives us negative 816, which is equal to the 3, and then we're going to divide through by that 3, and that gives us negative 272 kilojoules per mole for the FeO. All right, so hopefully working through some of these problems, it's tedious. As you can see, the typos can be made even by people who do it all the time. So hopefully just keep things straight, work your way through, take your time with it, and you should arrive at the right answers. If you have problems that you're struggling with, make sure you get in contact with me. I'd be more than happy to help. This slideshow then concludes chapter 6, and so we'll move into chapter 7 from here. All right, enjoy.